Hello, ladies and gentlemen, coming to you again, not quite live from One Take Studios, where today's topic is solving for a variable. Some of you may be asking yourselves, aren't we usually solving for a variable? And the answer to that question is yes, a resounding yes. There's a striking similarity with what we have going on today and what you have done in solving equations before. The difference is, when I wrote the objective today, I didn't say get the variable by itself, I said get a variable by itself. And so that potentially is the issue, is that this means that we've got possibly more than one variable. And so solving is not just x equals 5, solving is x equals 12k minus q. Why would we do this? Well, a couple of reasons. One, I do think it's a really good practice in helping you to actually understand how equations are solved so that you're not just looking at it and eyeballing it, that you actually understand the structure and how things work. But on top of that, in the world of business, in the world of spreadsheets exactly, things like that, formulas often need to be rewritten and reorganized so that they are easier to calculate, and this gives us a way to do that. I'm going to walk us through a couple of examples today because really you just need to see examples, and the more that you see, the better that you're going to get. The more practice you have, it'll be good. So I'm going to start with something not too crazy. I've just got x plus y, and I've got x plus y equals 5. So as you can see, I can't just solve for x because I've got a y. So let's say that I still wanted to solve for x. Somebody's going to have to give me a direction, unless I already know which variable to solve for. So usually if they give you an equation, they're also telling you which variable to focus on. And so I'm going to try to get the x by itself. And I'm going to do this the exact same way I would do this if there was a number sitting here. So if I say, where's the variable? Here, x. What's with the variable? A y. How is the y attached to the x? It's attached through addition. How do I break that attachment? How do I make the y go away so the x is by itself? Minus y. Undo plus y with a minus y. But again, I have to do the same thing on both sides. And this is what can really mess with people's minds sometimes. Is okay, this is delightful. My y's dropped out. Great. There's my x by itself. This is also great. What do you expect me to do with that? How do I do 5 minus y? Well, do what you can do and do not do what you cannot do. 5 and y are not like terms. So you can't actually squish them into one number or one term. You simply leave them as is. This says 5 minus y. I'm going to write down 5 minus y. That's it. That's my answer. Weirdly enough, that is my answer. My answer is x equals 5 minus y. So if you can't actually put them together, just write them. Exactly is what it says, 5 minus y. And we have solved for x, x is by itself, that's our new equation. So is it fun and exciting? Probably not. Can you do this? Yes. Don't be afraid, you got this. Okay, I want to look at another one, and let's go with, I'm going to go with this guy right here. I'm going to go with a negative 3 is equal to 4m plus n. Negative 3 equals 4m plus n. What shall we do this? Should we solve for m? Should we solve for n? What do you think? I think we should make our lives more interesting, don't you? Let's solve for m. And again, usually a textbook or a teacher would give you a direction, that's not an m, as far as which one they wanted you to solve for. And so we're going to go with the m this time. So I'm looking, here's my m. It's attached to a 4 through multiplication. It's attached to an n through addition. Again, if I'm solving, I am undoing order of operations, so normally order of operations would have addition as the last thing, so therefore it is the first thing that I will undo. Minus n, okay, plus n minus n, that's gone. I'm going to put my equal sign down for a second so I don't lose that. The 4m is still untouched. What is this though? That's a negative 3 and a minus n. What do I do with negative 3 minus n? I do the same thing I did last time. I don't stress out. I just say, okay, those are not like terms. This one has an n, this one doesn't. I can't actually put them together. So I will write negative 3 minus n. Negative 3 minus n. Just writing it out, horizontally instead of vertically. Do I have m by itself yet? Ooh, I do not. So this was a one-step. This is a two-step problem, but we can do this. The m still has the 4 attached to it, and it's 4 times m. So I'm going to break the multiplication attachment through division. I'm going to divide by 4 on one side, and I'm going to divide by 4 on the other side. What will that give me? Well, here the 4's are gone, and there is my m by itself. So if I'm trying to solve for m, oops, there we go, that's going to be a good sign. What do I do with all of this? Depending on what you've got going on, you can just write that. This says I've got negative 3 minus n, and I'd like to divide it by 4. So I can write negative 3 minus n divided by 4. That's an answer. That works. If you want to get into it a little bit more deep, you can divide each of these by 4. And so I'm going to throw that answer on there just for anybody who's interested. If you wanted to stop there, that's probably okay by me. This is divided by 4 divided by 4. What's negative 3 over 4? That's going to be negative 3 over 4. What's negative n over 4? Minus n over 4. We're just showing that both of these things are being divided by 4. So if you wanted to write your answer like this, you could do that too, and that would also be okay. All right, so alternate correct answer. I would take either one of those. This one is probably going to be more useful in the event that you are working towards graphing, maybe with the slope-intercept form kind of thing. All right, so again, strategies are similar. We're trying to get one of the variables by themselves. We're undoing everything around them just the way we normally would, but it's really weird looking and usually freaks people out a little bit. So a couple deep breaths. I'm going to do 2 more examples for you. All right, so we've got these 2 guys here. All right, I'm going to bring up, let's do something with a lovely fraction to begin with, shall we? So I've got x minus 2, and that's going to be all over y. And I'm going to set that equal to 6. And we're going to go with the directions solve for y. Solve for y. I like this one, and this is a really good example to pay attention to because the y that we're looking for is actually in my denominator. It's something that I'm dividing by. And that, I'm going to tell you right now, that messes up a lot of people, including my advanced algebra students, because they have a hard time understanding what to do with this. They just try to get rid of the x minus 2 and forget that even if you get rid of the x minus 2, the y is still on the bottom. So maybe we start by undoing the y first. That could have some value to it. This is dividing by y, and ultimately I want to have y by itself, but I don't want to divide by y. How can I undo a dividing by y? What if I multiplied by y? Times y divided by y, that would cancel, right? But if I'm doing that on one side, I've got to do that on the other side as well. So I'm going to multiply by y on this side, I'm going to multiply by y on this side. These guys cancel, gone and gone. What's left is the x minus 2. Equals, this says 6 times y. Whatever shall I write? I know. How about if I write 6 times y? And there's no more fraction, no more craziness. In fact, I almost even have y by itself. So I started by undoing the division. Now the y is over here. There's a 6 times y. How do I undo 6 times y? Break the multiplication with division. I want the y by itself, so I want the 6 to go away. Notice I'm thinking out loud. I want the y to be by itself, so I want the 6 to go away. It is important that you understand what you are doing and why, because otherwise you're just making up stuff and you're guessing. You might be right. You might not be right. So understand what's happening. I want the 6 to go away. I'm making it so that the 6 goes away. Hey, guys, there's the y by itself. Ta-da! And what am I going to do with this? Well, I can do kind of the same thing that I did over here. I can just call that x minus 2 over 6, and that is an acceptable answer. I do have y by itself, which is what I was trying to do, so yay me. Again, if you wanted to keep going, if you wanted to, we were saying that we have 2 things here divided by 6, and we could write them separately. So we could have the x divided by the 6 minus the 2 divided by the 6, and that's a possibility. Ooh, but 2 over 6, I can simplify that, can't I? 2 over 6, that's 1/3. So I might actually end up calling that, instead of 2/6, I might call that 1/3. And that would also equal y and be an acceptable, correct answer. So again, this answer is great, this answer is also good. depending on what you're doing, depending on what your teacher wants you to do, and depending on what kind of problems you have. Both answers are good. Last example. And I thought that I would give you something that was actually in context a little bit. Let's see if you recognize this. Capital A equals B times H, and this is going to be over 2. Do you recognize this? This is actually the formula for area of a triangle. Area is equal to the base times the height divided by 2. So this is a real formula that people work with frequently. And let's say, well, currently it's set up to find the area. But what if I knew the area and I needed to find the base instead? What would I do? I would take this and I would rearrange it. I would solve for B. So let's see if we can do that, taking an area formula that's currently set up to solve for area and rearrange it so that we are solving for the base instead. How will I get the B by itself? Again, just think about this. Okay, here's the B. It's attached to the H. How are they attached? That's multiplication. I'm going to need to divide to break that. How is the 2 attached? It's being divided. I'm going to need to multiply to break that. How about if we break these one at a time? Let's do that. Let's undo the divided by 2. How do I undo divided by 2? Times 2 and times 2. So this gives me 2a on the left side. And since the dividing by 2 and the multiplying by 2 will undo each other, there's b times h. I have one more thing to undo, keeping in mind this is my goal, getting this letter by itself. I already undid the 2. I need to undo the h. Why could I choose which one I wanted to undo first or second? Because this is multiplication and division. So essentially, they are the same level for order of operations. You can choose whatever you would like to work with there. So if I want b by itself, this is times h. I need to undo a times h with a divided by h. And divided by h here as well. Those guys will undo each other. There is my b by itself. There's my base. And what is this? I will probably just write it like this. 2 times a over h. So what is this saying? If I need to find the base of my triangle, I will double the area and divide by the height. And that will let me know what the base is for my triangle. So I've rearranged and I've solved for b. I know what my base is. All right. Patience. Focus, know what your purpose is, know why you are taking each step, and you'll get through this. All right? Practice, practice.